Okay, so let's get started. We're going to be taking a look at working with fail-safe strategy programming found on our Link G5 and G4X systems. Now, fail-safe strategies allow us to shut off our engine when we get into unsafe conditions. We want to shut our engine down if it's overheating, coolant temperature-wise. We want to shut our engine down if it's overboosting, if we have a turbocharged engine and we're exceeding where we want to run the engine safely and boost. If we have a wideband installed, which you will with your G5 or G4X, we want to shut the engine down if it becomes lean when we're at higher load conditions. And we also may want to shut the engine down if oil pressure gets too low and we have an oil pressure sensor installed and wired into our link. So we're going to take a look at these common type of strategies for fail-safe protection in our link programming. You can do a lot more with fail-safe strategy programming, but these are the common ones we'll use for a lot of engines, and this is what I generally set up for most clients' cars as I'm calibrating and tuning them with the link. Let's take a look at how to do this. It's pretty straightforward. We're going to move from our fuel page right here, and we're going to jump over into our safety specific page right here. In our safety specific page, let's click on this real quick. We're going to find that we have our RPM limiter that we covered and talked about in that last training module. We can see that's going to be our RPM limit table 1 here. Now we set this table up in that last tutorial based on coolant temperature. So we've called out where we want to rev our engine to, the highest limiter, based on if the engine is cold or the engine is overheating. Where the engine is operating in normal temperature, we generally set our RPM limiter here to where we want the actual limiter to be at. So this is one form of a fail-safe strategy baked right into our main rev limiter table. This is how I always recommend to set up your RPM limit table 1 here. So this table is going to serve us well for doing the very most basic fail-safe protection. So limiter, main limiter is in place, and then having a main limiter in place based on coolant temperature. So again, we don't want to over rev the engine when it's cold. We want it to warm up properly, have that limiter lower, and then hotter temperatures, we lower our limiter down so that we don't potentially run our engine into unsafe conditions hot. Okay, so that's going to be an overheating fail-safe protection. Again, we should understand what that all means. We covered that pretty extensively in that last training module. Now we're going to introduce our map limit table, otherwise known as boost cut, and we're going to introduce our general purpose rev limiter tables. The general purpose tables allow us to accomplish a limiter strategy based on anything we want to program in here. So it's really up to your imagination as to how you use these. We're going to be using them for oil pressure fail-safe protection and lean protection. So we'll learn how to go and implement that. Let's first turn our attention to our map limit table. Let's go and take a look at this and setting this up, and I'll just do a quick demonstration so we can see how this looks and what we need to look for in our time plot in a data log to see if a boost cut's turning on. So we're going to go to our map limit here, map limit mode. Let's turn this on. Now this is where we decide if we want to do an ignition or a fuel cut. Ignition cut is going to be a more aggressive style limiter strategy. It's more abrupt. It's definitely more abusive in terms of a limiter, but it sometimes is a better option for some engines. A lot of the times I choose ignition cut for a boost cut because I want to shut things down pretty quickly, and I'm using a boost cut on a turbocharged engine, so I don't want to necessarily cut the fuel. It could be problematic cutting the fuel if we're getting in high boost levels. We'd like to cut the spark down and keep that fuel flowing. So if we cut the spark, we don't necessarily lean out. Now, the only exception to that is going to be some engines that are sensitive to an ignition cut limiter. So an SR20 engine, for example, extremely sensitive to an ignition cut. So I always choose fuel cut for an SR20. Other engines seem to be not as sensitive. SR20s definitely get rocker arm float and rocker arm problems when you cut spark. The other thing to consider here is that what kind of fuel you're using. If you're running methanol fuel or nitromethane fuel and you're running boost, you probably don't want to cut your spark because you're pumping a ton of fuel flow through your engine, and a fuel cut strategy here would be a smarter idea so that you don't potentially hydrolock the engine on a limiter. That's another thing to keep in mind. Most engines are going to be on ethanol or petrol, so that's not necessarily a concern. The other thing to keep in mind, ignition cut, a little bit more of aggressive sound and limiter. Fuel cut's going to be a little bit softer type of limiter. So comparing the two, when you're choosing them, either will work for a boost cut, so it's not super critical that we choose one or the other than those situations I talked about. So if you have a typical petrol engine, it's turbocharged, you could choose either and it's probably going to be fine. I'm going to choose, in this case, ignition cut for my limiter strategy here. I'm going to click OK. I'll say yes to populate the default maps. Now, unfortunately, it populated our limiter 2 table with our map limit 1 table. It didn't pop in here, so we actually didn't want it to do that. we're going to ignore this up here because we're going to program the table right here. So let's go and unlock our window and double click here to our map limit table, and then we're going to talk about how to set this up. Now, when we're looking at the map limit table, we can base this on engine coolant temperature. That's one strategy. We have the ability to have another axis here in the table. We can get creative with this, really fancy with this. I like to keep things simple. And when we're using a map limiter table here, a boost cut, we're going to assume that you're probably running some type of boost control. If you're running a boost control solenoid, we're assuming you're running closed loop control. Closed loop control is the way to go with the link for boost control, and we're going to talk about that in tutorials, how to set that up. Now, if you're running closed loop boost control, again, highly recommend to do that, and that's the strategy I'd probably go after. We're going to set this table up very specifically. We're going to set it up based on boost target. The boost target allows the closed loop boost control a target to aim against and make its adjustments from. So if we have boost by gear, we'll have our targets varying by gear and RPM. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.